Two function models k and m are constructed to represent the population of deer in a forest. Both k of t and m of t represent the population of deer after t years for t is greater than or equal to 2. Interesting. I wonder if that's going to come into play later. If k of t is 200 minus 30 ln of t, and m of t is negative 5t plus 200, what is the first time t that the population predicted by the logarithmic? By the way, k is the logarithmic, and a model will be 10 years less. Ooh, look at me emphasizing that word with a bold font. 10 years less than the population predicted by the linear model, which would be m. You're the linear model. So I need to see when k is 10 less than m. So basically what I'm asking you is, when is k of t 10 less than m of t? Well, this is what I'm going to do. I'm going to run to my calculator, and I'm going to type this in the y sub 1 part. So I'm going to, in my calculator and in my TI 84 plus, I'm going to type in y sub 1 equals 2 hundo minus 30 ln of t. All right, pretty simple. In my y sub 2, I care about when this is 10 less than that. So basically, if I have negative 5t plus 200, I want this to be 10 less than that. So I just subtract 10. So basically what I do is, in my graphing calculator, I don't want 200, I want 110, because I'm making an adjustment. So let's run to our calculators and see what happens when we take care of that. And by the way, what I'm going to do is I'm going to run to my calculator and find the intersection of these two lines. So let's do it. All right, let's do it. We have y equals, and we're going to type in just what I said we'd type in, 200 minus 30 ln of t. So here's my ln button. Of course, it's not going to be t, it's going to be x, but we know what to do. That's the first equation. The second equation is going to be negative 5 instead of tx plus 1,900. Now, since we are dealing with a 200 that's floating around in y sub 1 and a 190 that's floating around, those are y-intercepts. So I'm not going to hit graph and expect to see anything. So what I could do whenever I don't see anything, usually something that kind of works, is going to be zoom fit, which, I scroll up to 0, or I just hit 0 and hit enter and zoom fit. Now here's the thing. Let's just make believe that I'm blindly going to do this and not think at all. Okay. If I go to second calc and hit intersect, right? And I'm going to think, oh, okay, well, there's an intersection right there. Let's plug it in. Well, all right, let's do it. Let's plug it in. Let's go to the first curve, hit enter just to the left of it. Let's go to the right of it and hit enter just to the right of it and hit enter again. I get 1.922. And I'm like, oh, great, 1.922. That's awesome. Now, here's the issue. Do you remember in the original problem, t is supposed to be greater than or equal to 0. This isn't greater than or equal to 0. This isn't my answer. Now, if I notice my graphs, okay, this is the ln1, okay, and if you look back, since it's negative ln, that's why it's curling down like that. It's doing the mirror reflection over the x-axis. This is the linear guy. This is probably going to keep going down and to the right, and this is going to keep leveling out. And so these guys are going to intersect again off here, off screen. So what I need to do is maybe I just need to hit zoom out a little bit and see if I get another intersection. Oh, look at that. Another intersection, just like I predicted. So this original guy isn't going to do it. So we have to hit intersect again. So second trace intersect. Let's go over here, make sure I get close enough, but not too close, just to the left of it. Hit enter. Let's move just to the right of it. Hit enter. Always hit enter for guess. And it's giving me 13.7077. So 13.708 should be my guy. So I'm going to run back to my calculator, hit 13.708, and get my answer. Tricky, 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 tricky problem. This was a tricky problem. First things first, it couldn't be simple where they were just like, hey, find out when these guys are equal to each other. They had to throw this part in there. Then they also had to throw this part in there. So it's a tricky problem. So be prepared for tricky problems like that guy right there. Hope this helps.